Hello friends and welcome back to my channel. I am your friend Ashfaq. In our last video we had installed the Terraform on the Windows 11, and in today's video we will deploy the AWS VPC using Terraform, and then we will deploy the EC2 instance on that VPC using Terraform. Let's get started. If I go to my AWS console and inside the VPC, you can see I am not having any VPC as of now, and we are going to create the VPC using Terraform. First of all, I will have to install the AWS CLI in my system. My system is 64-bit, so I will download this MSI file. I will install this exe. Finish. I will go to command prompt and I will give here the command AWS -- version. So AWS CLI has been installed in my system. In my local system, I will create one folder for the Terraform files. I will open the Visual Studio Code. I will open the created folder. I will create the file and give the name main.tf. Now actually I have to register the AWS provider in the Terraform. So I will give these commands in the Terraform to register the AWS provider. This would be the source, this is the version, and our provider would be registered for the region AP South 1. I will save this file. I will open the terminal and I will first of all do the Terraform init. Okay, so AWS provider has been registered. Now I will go to my AWS console. I will go to IAM users. add user. I will give the name cloud admin. Next, attach policies. I will give the administrator access. Next, create user. So cloud admin user has been created. I will go to user, security credentials. Under the access keys, I will click on create access key. CLI, I will tick here. Next, create access key. I will copy the access key. I will go to VS Code and I will give here the command AWS configure. I will paste the access key and hit enter. I will now copy the secret key and I will paste it here and hit enter. So we have successfully logged into the AWS through the CLI. Now I have to create the VPC. So I will give these commands. Resources AWS VPC, and this would be the name of our VPC, and this is the CIDR block for our VPC 10.0.0.0/16, and tenancy would be default. I will save the file and I will give here the command Terraform apply. I will give the value yes and hit enter. Okay, so one resource added. If I go to console and I will type here VPC, so you can see here we have one VPC available which we have just created, and the CIDR block is 10.0.0.0/16. Okay, now I have to create the public and private subnet. So with this script we will be creating the public subnet. Resources AWS subnet, this would be the name of our subnet, and VPC ID it has taken from the previously created VPC. This is the name of the VPC, sorry, this is the resource for the VPC, and this is the name of the VPC which we had given during the creation. And this would be the script for the private subnet. Resources AWS subnet, and this would be the name of our private subnet, lab private subnet, VPC ID, and CIDR block for the private subnet would be 10.0.2.0/24. I will save the file and here I will give the command Terraform apply. Enter value yes. So resource created 2. If I go to AWS console and go to subnets, so these are the 2 subnets which has been created just now with the CIDR block. To create the security group, I will give this code in which resource is AWS security group, and this will be the name of our security group, and our security group will actually allow the port 22 for the any IP, and this code will allow the port 22 from anywhere, and this will allow the output traffic for any port towards any IP. So this is the complete code to create the security group and to add the inbound and outbound rules to it. I will save the file and I will give the command terraform apply. Yes. So one added means security group has been added on the AWS console. If I go to security group, so you can see here our security group has been created. To create the internet gateway, I will give this code resources AWS internet gateway, and this will be the name of our internet gateway. This is the VPC ID, and this would be the tag. So this is my complete code to create the internet gateway. I will save the file and I will give the command terraform apply. Yes. So resource 1 added. If I go to AWS console and if I go to internet gateways, you can see here internet gateway has been created. Now I have to create the elastic IP and the NAT gateway. NAT gateway will actually map the private IP to the public IP for the internet access to our subnet. So to create the elastic IP, I will give this code resource AWS EIP, and this will be the name of our elastic IP. And to create the NAT gateway, I will give the code resource is AWS NAT gateway, and this will be the name of our NAT gateway. And allocation ID is AWS EIP, which is the resource for the Elastic IP, and this is the name of our Elastic IP. And subnet ID, this is the resource name AWS underscore subnet, and this is the name of our public subnet, and we are going to tag to our NAT gateway as lab NAT gateway. To ensure proper ordering, it is recommended to add a explicit dependency on the internet gateway for the VPC. To add the dependency, I will give this command in the code. So this is actually resource for the internet AWS internet gateway, and this is the name of our internet gateway. So this is the complete command to create the Elastic IP and the NAT gateway. I will save the file and I will give the command Terraform apply. Yes. So two resource has been added. If I go to AWS console and go to NAT gateway, so this is the lab NAT gateway which has been created just now, and this is the Elastic IP which has been created just now. Now I have to create the public and private root table. So I will give this code to create the public root table. This is the resource AWS root table, and this will be the name of our root table, lab VPC public root table. This is the VPC ID, and all the traffic for the internet would be forwarded to the internet gateway, and this is the tag which we are giving. I will now give the code for the private root table. Resource is AWS root table, and this will be the name of our root table, private VPC lab VPC private root table. And this is the VPC ID. All the traffic for the private root table will be forwarded to our NAT gateway. and this is the name of our NAT gateway, and this is the tag which we are giving to private route table. I will save the file and I will give the command terraform apply. Yes. So two resource has been added, which means our public and private route table has been created. To create the public route table association, I will give this code in which this is our resource AWS route table association, and this will be the name of our route table association, and this is the subnet ID for our public subnet, and this is the ID for our public route table. This code will actually associate our public subnet with the public route table. I will now give the code for the private route table association, in which this is the resource AWS route table association, and this will be the name of our private route table association. This is the ID for the private subnet, and this is the ID for the private route table, and this code will actually associate our private subnet with the private route table. I will save the file and I will give the command terraform apply. Yes. So two resource has been added, which means public and private route table association has been created. To create the EC2 instance using Terraform, I will give the code. In this code, this is the AWS resource AWS instance, and this would be the name for our resource lab web server, and this is the AMI ID. If you go to AWS console and if you go to EC2 instance, launch instance, and you select your instance, so you can find the AMI ID here, and this AMI ID is region specific. If you select the some another region, this would get changed, and this is the AMI ID we are using here in the code. Instance type T2 micro, and key pair name, this is the key pair name which is available in my account. You will have to use the key pair name which is available in your account. This is the ID of the public subnet, and this is the ID for the security group which we had created previously. associate public IP address true, volume size would be 20 GB, and it will delete on termination true. It will delete the volume when the instance is deleted, and this would be the tag which would get assigned to our EC2 instance. So this is the complete code to create the EC2 instance in this VPC. I will save the file and I will give the command terraform apply. Yes, it gave me the error. I will retry, but this time in my code instance type I will select T3 micro. I will save the file and I will try again. Yes, okay, one resource added. I will go to my AWS console. I will go to EC2 instances. So you can see our instance is available, which is initializing. I will select the created EC2 instance, connect, connect. I have allowed the password authentication for the EC2 instance. I will now reset the password for my username. I will now restart the SSD service. I will copy the public IP address of the EC2 instance and I will open the putty. I am able to access the EC2 instance. through the putty using public IP. Which means all the routing are working properly, as I am able to access the EC2 instance from my system through the public IP. By this way, you can create the AWS VPC using Terraform code, and you can also create the EC2 instance in that VPC using the Terraform code. The link to download this complete code I will provide you in the description. Hope you find this video helpful. Lot of effort went behind this video, so do subscribe to my channel to encourage my work. Like the video, share it with the friends and spread the knowledge. I will see you in the next video. Thank you.